Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we're looking at our 8.4 notes. 8.4 is all about what's known as a natural logarithm. So the good news is when we talk about natural logs, it's still practically the exact same idea as a log. But let's just go ahead and introduce whatever a natural log is. Here's what it says at the top. The most frequently used base for logarithms is e. That is, log base e of x equals ln of x. Please note this is an L, not an I. A lot of people get that confused for some reason. But what we're noticing here is if you have log base e, another way you might represent that is with ln. Notice ln does not show its base. It's just assuming or implying that it's a log with base e, where ln of x is what is known as a natural logarithm. Natural logarithms are important in calculus and many scientific applications. Here is what Elizabeth Staples said. There's something about the universe that makes the existence of E unavoidable. You can't do the sciences without E and the natural log. Once you start getting involved in science and you start learning about different fields of science and you start applying that knowledge, you'll notice that E and natural log have to be there in order for specific topics to actually work. You can't do the sciences without E and the natural log. Let's go ahead and look at what we can do with natural logs. One thing we did with logs is we converted between forms. We converted between exponential and logarithmic form. Same idea here. I have e in this first problem. So if I want to change this to log form, I would make it log base e. And remember, you switch the other two parts. Identify the base, switch the other two. Okay, but log base e, this part here, we said that's the exact same thing as natural log, as just ln. So generally, we'll skip this middle step and just go straight to the end, but it does help you understand where we're getting ln from. Number 2, I want it as a log. I see the base is e, so if I want log with base e, that is ln. We switch the other two. 7 and 8, same idea, but notice we're in log form right now. ln, again, that's log with base e. So if I want exponential form, I make it an e. I switch the other two. The 4 goes to the other side. The 3x comes over here. Be careful. What I've been seeing is lots of people want to write this for some reason. We need exponential form, though. Exponential form means there's an exponent. So I've heard people say, okay, that just means get rid of the parentheses. No, that is not what it means, right? An exponent means the exponent is up top. The 3x needs to be raised. It is the power. Same idea with number 8. Identify the base, switch the other two. Converting forms should be a quick process. Other processes we've learned with logs is expanding and condensing them. For example, number 9 and number 20 here. Remember that we want to pay attention to the signs. Whatever the sign is tells you where these different parts go when we make this a singular log. The other thing we pay attention to is any of the values in front of the logs. If there's values in front, that is an exponent on whatever is on the inside of it. So what I notice is there's this positive 3 natural log of x. That tells me the x will be on top of our fraction, where the 3 is the exponent on it. The 3 in front is the exponent. I then notice this minus. Minus tells me the 3 will go on bottom of this log. There is no number in front, so there is no exponent on the 3. I notice the last one is a plus. Again, plus means it is on top. Again, there is no value in front, so there is no exponent. We've looked at this process quite a bit. This should be a process that's pretty quick for us at this point. The only difference is we're using natural log instead of log with some base. 20, exact same idea. We separate stuff wherever it's multiplying, so the 9 and x will get separated. We also separate it where the division is. And it's the same rules. Natural log of 9 is on top, so it's going to be positive. The x was on top as well, so it will also have a plus in front of its natural log. The y to the fourth is on bottom, but since the y has an exponent of 4, that 4 would just move in front. One thing I like to ask people is, okay, why do I not just write it like this instead, where the 9 is in front of the natural log with x? Well, realize the 9 was not an exponent, right? In order for a number to be in front, it must be an exponent. The 9 was not, so we have the top answer instead. Another thing, realize you don't need the positive or the plus sign in front of that first one. Not necessarily needed there. So quick ideas for the beginning. Now let's go ahead. Let's talk about some solving that we might do. On this first problem, we're solving with an exponential equation base e. Whatever the exponential part is, you need it by itself. We need to get rid of the 4 first. Realize the 4 was attached to the e. That meant it was multiplying, so I divide it to the other side. Here's what I've been telling people. If your variable is stuck somewhere, right? It's stuck in the exponent. Let's go ahead and change or convert forms. So if I have an exponential form right now, e to some power, to get the variable down, you can convert forms. That would give us natural log of 6 equals 3x plus 8. Okay, ln of 6, that's just a value. We could type that in our calculator and find it. But let's just start to move stuff. I could subtract the 8. Realize that 8 does not combine with the 6. The 6 is on the inside of the log, so the 8 is not allowed to join it. We could divide the 3 over, do that on both sides. Once you do that, realize that 3 divides everything on that side, and we get an answer. At this point, you could just type all of this into your calculator to find your answer. If you do so, you'd get a negative 2.069. Realize it is a never-ending decimal there because of this log. But you can round to a few decimals. 2 or 3 is always a good idea. So negative 2.069. That looks like a good answer now. Let's look at what we'd have to do if our process was with a natural log in it instead of an exponential now. Well, same idea. You still want to get that part by itself. So let's move the 14 to the other side. Okay, but once we do that, everything else that we need to move is stuck inside the natural log. But again, if it's stuck somewhere, we said let's change the form. So if I have a natural log, I know the base is e. I can change it to exponential form by switching the other two parts. Now I can just start to move stuff to the other side. So e to the negative 4 plus 4. Realize the 4's do not combine. That negative 4 is an exponent, so you cannot combine it with these other parts. You could divide it by 7 on both sides, and you would end up finding your answer. E to the negative 4 plus 4 all over 7. So at this step, again, type it into your calculator. E is a number, remember. It's like 2.7 something, something, something. Okay, so you could type it in your calculator to figure out the values. If you type it into Desmos with all of that, you get 0.574 and some other decimals after that. And there is our solving process. Solving with a natural log versus solving with an exponential where the base is e. That is our 8.4 video. Thanks for watching. I'll see you guys next time.